Hi viewers, welcome to Briksham channel. Learn mathematics easily. In this part, we are going to learn about Karl Pearson's coefficient of correlation or product moment correlation coefficient. And the Karl Pearson's coefficient of correlation or Karl Pearson's correlation coefficient is denoted by the letter R. So the definition of this Karl Pearson's coefficient of correlation is it is covariance between the two variables divided by the product of their standard deviations, right? So in math expressions are equal to covariance of x comma y divided by standard deviation of x multiplied by standard deviation of y. Okay, so the correlation coefficient can be defined as covariance between two variables x and y divided by standard deviation of y. And we have two formulas to find the correlation coefficient. So the first one is R equal to summation xy divided by square root of summation x square into summation y square, where small x is equal to x minus x bar and y is equal to y minus y bar. So in this, to apply this formula, so first we have to find the arithmetic mean of the variable x, then arithmetic mean of the variable y, then find small x, that is by using this formula, that is deviation of values to the arithmetic mean. X minus x bar and y minus y bar we have to calculate and mark it as x and y, then substitute in this formula, right? Then next one, the next formula is R equal to n into summation xy minus summation x summation y divided by square root of n into summation x square minus summation x the whole square multiplied by square root of n into summation y square minus summation y the whole square. So this one represents the covariance of x comma y, and this one represents the standard deviation of the variable x, and this one represents the standard deviation of the variable y, right? Next one, properties of correlation coefficient. We must note this point that correlation coefficient must lies between -1 and +1 always, and correlation coefficient is independent of change of origin and it is independent of change of scale, because here we are not considering the variable like dependent or independent. Both the variables we are treating as equal, therefore it is independent of change of origin and change of scale. And the correlation coefficient is a pure number. It does not have any unit of measurement like centimeter, meter, like that. Okay, it is exactly a pure number. It lies between -1 and +1. These are all the properties of correlation coefficient. Interpretation of the correlation coefficient. Okay, we are calculating the correlation coefficient by the above said formulas or by the scatter diagram. If the value of R is 0, then we can say that there is no correlation, that is absence of linear correlation, or we can say no correlation. And R equal to +1 indicates perfect positive correlation. R equal to -1 indicates perfect negative correlation. Then R less than 0.5 indicates low positive correlation. That is, if R, the correlation coefficient R lies between 0 and 0.5, then we can say it as low positive correlation. And the correlation coefficient is between 0.5 and 1, we can define it as high positive correlation. Okay. And the correlation coefficient R is between -1 and -0.5, then we can define it as high negative correlation. And the correlation coefficient R is between -0.5 and 0, then we can say it as high negative correlation. Okay, so here in these four intervals, we are not including the point 0, +1 and -1. Now we will see the problems one by one. The first problem example gives the following table gives the aptitude test scores and productivity indices of 8 randomly selected workers. The aptitude score and productivity indices of 8 students are given. We have to calculate the correlation coefficient between the aptitude test score and productivity indices. So the aptitude test score, we can take it as the variable x, and the productivity indices, we can take the variable, that is productivity index. We can take it as the variable y. So now we will go with the first formula. So for that, first we have to calculate the arithmetic mean. So first we will add all these values. So the arithmetic mean can be calculated by using this formula, x bar equal to summation x divided by n, which is equal to summation x is 480 divided by n is 8, that is the number of observations taken is 8, right? So 480 divided by 8 will give you 60. And we have to find the arithmetic mean of the variable y, that is we can denote it as y bar, which is equal to summation y divided by n, which is equal to 552 divided by 8, which is equal to 16. So now we have to find a small x. So x bar equal to 60 we have identified. Okay, so now we have to take from this. Now we are going to find the deviation between the values and the arithmetic mean. So 57 minus 60 will give you minus 3. Then 58 minus 60 minus 2. 59 minus 60 minus 1. 59 minus 60 again minus 1. 60 minus 60 0. 61 minus 61. Then 62 minus 62. Then 64 minus 64. Okay, and y minus y bar. That is 67 minus 69 is minus 2. 68 minus 69 minus 1. 65 minus 69 minus 4. 68 minus 69 minus 1. 72 minus 69 3. Then again 3. 0. Then 2. Then we have to find x square. So square this column. 3 square is 9. 4 1 1 0 1 4 16. And what about y square? It is 4 1 16 1 9 9 0 4. And xy, so minus 3 multiplied by minus 2 is 6. 2 4 1 0 3 0 8. So now we have to find the total. Summation x square is 36, summation y square 44, and summation xy is 24. Right? So now we will substitute all these values in the formula. So r equal to summation xy divided by square root of summation x square into summation y square. So the value for summation xy is 24 divided by square root of summation x square is 36 and summation y square is 44. Upon simplification, we will get the value for this as 0.6030. Therefore, the correlation coefficient is 0.6030. It is greater than 5, greater than 0.5. Therefore, we can say that there exists high positive correlation between the aptitude test score and productivity indices. Okay, we will see the interpretation part now. Yes, R is greater than 0.5. That is, it lies between 0.5 and 1. Hence, there is high positive correlation between the aptitude test score. Come to the second example. So these are all the details given. Sum of squares of deviations from arithmetic mean, sum of product of deviations of x and y from their respective means, and a number of observations, right? These are all the details given. So now we will see the solution. So in this problem, number of observations n is given as 10. Then sum of product of deviations, right? That is summation of x minus x bar into y minus y bar, which is given as 2350, right? Then sum of squares of deviations from arithmetic mean. The deviation from arithmetic mean, we can denote it as x minus x bar, and the square of the square of deviations. Okay, so this is the square of deviations and sum of squares of deviations, that is summation of x minus x bar the whole square, which is given as 8250. Okay, and similarly summation of y minus y bar the whole square is given as 724. Substitute the values here. Summation xy is 2350 and summation of x minus x bar the whole square is 8250 and summation of y minus y bar the whole square is 724. So upon simplification, I will get the value for this as 0.9615. So here also the value for r is greater than 5, greater than 0.5. Hence we can say that there is high degree of positive correlation. Next example, compute the correlation between the advertisement expenditure and the sales. The x represents the advertisement expenditure and y represents the sales. So here x and y values are given. We will go with the second formula. That is, to apply that formula, we need to find x square, y square and xy of x and y. Now we have to square the first column, second column, as well as we have to done second column. So 10 square is 100, then 12 square 144, then 324, 64, 169, 400, 484, 225, 25 and 289. And what about summation y square? That is, y square, 88 square will give you 7744, 6, 7396, 7396, 8464, 9216, 8836, 7744, 7225. And xy, it is 880, 1080, 1692, 688, 1131, 1840, 2112, 1410, 440, 1445. Now we have to add all these columns. So summation x is 140, summation y is 900, summation x square is 2224, summation y square is 81,130, summation xy is 12,718. Now we will substitute all these values in the form. This is the formula to find the correlation coefficient. That is the second formula. Right, now we will substitute all the values. So n is 10 multiplied by summation xy is 12,718 and summation x is 140, summation y is 900 divided by 10 into summation x square is 2224 minus summation x the whole square. So 140 the whole square, and here n is 10 multiplied by summation y square is 81,130 minus summation y is 900 the whole square. Okay, so the value for this is, so 1180 divided by square root of 2640 multiplied by 100. So which is equal to 0.6370. Okay, so from this we can conclude that the correlation coefficient R is greater than 0.5. Therefore, there exists high degree of positive correlation between the variables x and y, that is advertisement expenditure and sales. Okay, and another problem also, the values are directly given. By using the same formula, we can find the correlation coefficient. Next, some important formulas we have. The coefficient of determination will give you, that is, how do you calculate the coefficient of determination? It is the square of correlation coefficient. So after calculating the correlation coefficient, square the value, that will give you the coefficient of determination. And the coefficient of non-determination can be calculated by using the formula k square equal to 1 minus r square. And coefficient of alienation means it is square root of coefficient of non-determination, that is k equal to plus or minus square root of 1 minus r square. And what about standard error? So standard error is denoted by 1 minus r square divided by root 10, and the probable error is 0.675 multiplied by 1 minus r. Okay. If you are comfortable, kindly like, subscribe and press the bell button for further notifications. Thank you.